Okay, I'm just going to show you how to fill in the unit circle without having any notes in front of you whatsoever. The first thing you want to start with is the degrees. So notice that you have blanks for all the degrees around the circle. Well, you know your circle starts at 0 degrees. Every big space, every big wedge is 30 degrees. So from here to here, you go from 0 to 30. Now every little wedge is another 15 degrees. So if I'm at 30 here, I'm going to add another 15 to get to 45 right here. Then another 15 to get from here to here, and that's going to be 60. Another 30, and this will give us 90. And you can kind of just repeat this pattern. Another 30 would give us 120 right here. Another 15. Another 15. Another 30. So I'm just going to keep going. 30, 15, 15, 30, 30, 15, 15, and then we do want to end, I know there's no space for it, but you want to end here at 360 degrees. Okay, so we got all the degrees in there. We're now going to fill in all the radians. So the radians are going to go in these other spaces. So remember that radians also starts with 0. What I would do is try to remember these 4, or actually 5 major radians. So you have 0, you have pi over 2 at 90 degrees, you have pi, you have 3 pi over 2, and then you go full circle makes 2 pi, which makes sense because halfway there is just a single pi. Alright, but now we have all these other radians. So the way I remember this is pi over 2 is at the top here, and then you have pi over 3, because, it goes 2, 3, 4. Try to remember that there's no pi over 5. It just goes to pi over 6 instead. Now, the great thing about the unit circle is all the symmetry within the circle. So this point right here, due to symmetry across the y-axis, will correspond to this. And it's going to be some variation of pi over 3. Now, actually, it's going to be something pi over 3. There's going to be a number right here. We'll just keep that in mind. Then, just by symmetry, I have pi over 4, but there's going to be another number here. So I'm going to try and leave, I should have space there, pi over 6. Again, by symmetry, this would be pi over 6, pi over 4, and pi over 3. Again, by symmetry, I have pi over 3, pi over 4, and pi over 6. Now, again, I left room for numbers on all these, except in the first quadrant. This is 1 pi over 3, 1 pi over 4, 1 pi over 6. So just go by my logic here real quick. We're working with whole numbers, and so right here I have 1 pi over 3. Well, what's going to go here then? Well, if I put 3 pi over 3, for example, what would happen if I put 3 pi over 3? Well, the 3's would cancel, leaving you with just pi. But you already have pi right here. So this can't be 3 pi over 3, and it can't be 1 pi over 3. So this has to be 2 pi over 3. So try and get that logic down. In the same fashion, I already have 1 pi over 4 over here. Now, so can it be 2 pi over 4? Well, no, because 2 over 4 reduces to 1 over 2, or pi over 2, which you already have. It can't be 4 pi over 4, because 4 and 4 reduce to 1, which is just pi. So this has to be 3 pi over 4. Likewise, right here, this can't be 1 pi over 6, I already have that. It can't be 2 pi over 6, because 2 over 6 is 1/3, and you already have 1/3 pi right here. It can't be 4 over 6, because that would reduce to 2/3, which you already have right here. It can't be 6 over 6, because that's just 1 pi. So this has to be 5 pi over 6. Okay, then you get to the third quadrant. So we've gone 5 pi over 6. This would technically be 6 pi over 6, so this must be 7 pi over 6. Okay, right here we had 3 pi over 4. This would technically be 4 pi over 4, so this must be 5 pi over 4. And again, likewise, this is 2 pi over 3. This would technically be 3 pi over 3, so this must be 4 pi over 3. Alright, we hit 3 pi over 2, but we already have that there. Try to memorize that again. And then over here, okay, so we stopped at 4 pi over 3. Now I have something pi over 3. So think about this. It can't be 6 pi over 3, because 6 over 3 is 2, and 2 pi is already on the circle. So this must be 5 pi over 3. If you just keep reasoning this out, we stopped at 5 pi over 4, but it can't be 6 pi over 4 because 6 over 4 reduces to 3 over 2, and you already have 3 pi over 2 right here. It can't be 8 over 4 because 8 divided by 4 is 2, and 2 pi is already on the circle. So this must be 7 pi over 4. And then you have this one. So let's see, we had 7 pi over 6 here. So can it be 8 pi over 6? No. Can't be, because 8 over 6 would reduce to 4 over 3, which you already have. It can't be 9 pi over 6 because 9 over 6 reduces to 3 over 2, and you already have that. It can't be 10 over 6 because that would reduce to 5 over 3, which you have right here. And it can't be 12 over 6 because 12 divided by 6 is 2. So this must be 11 pi over 6. Okay, the last thing I'm going to show you is how to fill in all the xy coordinate points. Let's go ahead and there's 4 easy points on the circle, the ones at the top, bottom, left, and right. Remember that your radius is 1, so this point must be 1, 0, as if it's in the xy coordinate plane, which it is. It is in the xy coordinate plane. Up here you have 0, 1, because it's 0 on the x, 1 on the y. Now over here, this is the negative x-axis, so this is -1, 0. This is the negative y-axis, so this is 0, -1. Now there's a nice, cool little trick that you can do to fill in these points. The first thing you could do is, and I don't know if you notice this, but every fraction has a denominator of 2. So I'm going to go ahead and just right away around the circle, every denominator is going to be a 2. I know this with certainty. So let's just get that out of the way real quick. Now check this out. See how the x-coordinate at 90 degrees, this is the exact method I will try to memorize here, by the way. See how at 90 degrees, the x-coordinate is 0? A nice little trick to fill this in by memory is if the x-coordinate here starts at 0, count 0, 1 on the x-coordinate, then on this one 2, then on this one 3. Likewise, if you start at 0 here on the y, then it counts 1, 2, and 3. And then you put square roots on all of your numerators, although remember that the square root of 1 is just 1, so I don't actually need to put a square root on my 1s, even though we kind of are, but the square root of 1 is 1. But everything else gets a square root. Now, let's talk about the symmetry here real quick. These points are symmetric, meaning that this point over here is the same exact as this point over here, except over here the x-axis is negative. So what I can do is I can copy this point, pi over 3 to 2 pi over 3, like that, except in this quadrant, okay, so in this quadrant this is xy, but in this quadrant all my x's are negative because this is the negative x-axis, but it's still the positive y-axis. So that means that as I transfer this over here, I just need to make my x-coordinate negative. Now I'm going to keep my y-coordinate positive, however. So let's just keep repeating that process. I'm going to transfer this over here. So I have square root of 2, but I need to make my x-coordinate negative. Again, transfer this over. I have square root of 3 and 1. Let's just copy that over. But I need to make my x-coordinate negative. In this quadrant, both x and y are negative. So in this quadrant, x and y are both negative. So you can copy this point down here. So I have square root of 3 and 1. Would make both your x and your y negative. Again, transfer this down here. Again, we can transfer all this to the symmetry and make both of them negative because of the quadrant we're in. Again, transfer this down and make them both negative. And one more time, let's go ahead and transfer these over. And then in this quadrant, your x is positive, but in this quadrant, y is negative, so it's x negative y. So we just have to make all our y coordinates negative. And that is how you fill in a unit circle without actually having to look at anything. It's all based on logic and reasoning and some patterns.